In this video, we're going to be looking at relative and conditional frequencies. So we can display values in a two-way table as frequency counts, as we did in the previous video, or we can do them as relative frequencies. And so we have three different types of relative frequencies. The first is the joint relative frequency, and that is the ratio of the frequency in a specific category and total number in that category. And then there is the marginal frequency, and that is the sum of the joint relative frequency in a row or column. And then we have conditional relative frequency, and that is the ratio of a joint relative frequency to the marginal relative frequency. And this can be found using a row or column total of a two-way table. And all of these can be interpreted as probabilities. So it's kind of a lot, so let's look at some examples so we can see visually what these three different types are. So in this first one, we're going to use the results to make a two-way table that shows the joint and marginal relative frequencies. So the joint ones are going to be in these four boxes, and the marginals are in the totals. So I want to first find the joint relative frequencies. And so I look here, and how I do this is I'm going to go to attending and junior up above here. I see that's 42. And I'm going to divide it by the total number of students. And so that is 220. So when I do 42 divided by 220, that's going to be approximately 0.191. So what that tells me is that 19.1% of the students in this survey are juniors, and they are attending the concert. Okay, and then I'm just going to keep on going. So the next one, the number of not attending is 64 that I see up here, divided by 220, and that is approximately 0.291. And then 77 divided by 220, and that is approximately 0.35. Or sorry, not approximately, that one's actually equal to 0.35. And then I have 37 divided by 220, and that is approximately 0.168. So that's how I find the joint relative frequencies. And then I want to find the marginal relative frequencies. And so to find those, I'm just going to take the sum across the rows and the sum across the columns. So for this first one, I do 0.191 plus 0.291, and I get 0.482. For this next one, I do 0.35 plus 0.168, and I get 0.518. And then I want to add the columns. So 0.191 plus 0.35, I get 0.541. 0.291 plus 0.6168, I get 0.459. And then for this last one, I can either add the column or I can add the row. Either one, you see it's going to add up to 1. And you'll know that you've done this right at the end if you have 1 at the very end. This should always be 1. I'll make a note of that. And so some other ways you can interpret it, this 0.518, for instance, that means about 51.8% of the students in the survey are seniors. Or the 0.459, I can interpret that as 45.9% of the students surveyed are not attending. Okay, and then the second part kind of goes along with number 1, and that says to use the results to make a two-way table that shows the conditional relative frequencies based on the row totals. So now I'm going to use what I found in this first problem, these values, and find the conditional relative frequencies. Now I'm going to do it based on row totals. So I want to do it based on the total I see here, so 0.482 and 0.518. So to do that, I'm going to take my attending junior, that relative frequency, which I found to be 0.191, and I'm going to divide it by the total marginal frequency for that row, since the question was asking for row totals. So I'm going to divide it by 0.482. And so when I do that, I get approximately 0.396. Do the same thing with the next for non-attending. So I'm going to do 0.291 divided by that row total, which was 0.482. And I get approximately 0.604. And then do the same thing with the second row. So 0.35 divided by that row total, which is 0.518. And I get approximately 0.676. And then my last one, 0.168 divided by the row total of 0.518. And I get approximately 0.324. So if I'm interpreting this table, that last one, for instance, 0.324, that would mean that given that a student is a senior, the conditional relative frequency that he or she is not attending the concert is about 32.4%. Okay, let's look at two more. So I want to use the results to make a two-way table that shows the joint and marginal relative frequencies. So for this first one, I have male, female, and total. So I want to take the yes male number, so this is 23, and divide it by the total, which is 61. And so when I do 23 divided by 61, I get approximately 0.377. Then I can go to the next one. No, that number was 4 divided by the total. And do 4 divided by 61. I get approximately 0.066. 19 divided by 61. And I get approximately 0.311. And then my last one, no, female, that number was 15 divided by the total number of students, and I get approximately 0.25. No, 246, sorry. And then I just need to add across and down below to find those marginals. So if I do 0.377 plus 0.066, I get 0.443. 0.311 plus 0.246, I get 0.557. And then when I add up above, I see that equals 1. So I know that part is correct. Now I need to add the columns. 0.377 plus 0.311, I get 0.688. And then 0.066 plus 0.246, I get 0.312. And I see if I add across here, 0.688 plus 0.312 equals 1, so I know I'm good. Okay, now we're going to use those results to find the conditional relative frequencies, and we're going to do this based on column totals. So that is a mistype right here. I'll have yours correct. This should be column totals. And so that means I'm going to be looking at these two totals that I'm going to divide each of my joint relative frequencies by. So that first one was 0.377, and I'm going to divide that by the column total, which is 0.688. So when I do 0.377 divided by 0.688, I get approximately 0.548. And then I'm going to keep on going. So I want to have 0.066 I'm going to divide that by that column total, which is 0.312. And I get approximately 0.212. The yes female, that relative frequency was 0.311 divided by the total marginal relative frequency of 0.688. And so 0.311 divided by 0.688, and I get approximately 0.452. And then the last one, I want to do 0.246 divided by that column total, which is 0.312. So 0.246 divided by 0.312, and I get that this is approximately 0.788. And so here you know that you do it correct if your columns end up adding to equal 1, and I see with both of these they do.